So I'm going to go through the warm-ups we did in class today and walk you through them one more time. Stop the video, slow it down, do it along with me as you go. So all of these rules, we decided we would figure out what kind of function they were before we went ahead and found a function rule. So on the side, I'm going to look at the differences between the terms and see if I can tell what kind of function rule this is. So my first differences are 13, then 17, and then 21. It cannot be linear because my first differences aren't the same. My second differences, however, are the same or constant, so it's a quadratic function. So I'm going to be looking to write a quadratic function rule. One way to do that you learned in the flipped lesson video was to look at the factors of the term values, the sequence values, and see if we notice any pattern that would allow us to come up with two linear rules to describe what's going on. We're good at writing linear rules. So I'm going to factor the term values. So for 13, which happens to be prime, I know that that's 1 times 13. I know that I need to follow some sort of linear pattern, so 13, 15 would be good. Sometimes this takes longer if you need to write out all the factors in order to see a pattern. 51 could be 3 times 17. And backing up then, my 0 term would be 0 times 11. And I want that 0 term, or that 4th term, so that I can see what's going on with my two separate patterns. So I see two patterns emerging that I need to write rules for. I need a pattern emerging that when I use the 4th term to get the 0 value, I need one rule that generates a 0 and one rule that generates an 11. For the 5th term, in order to get 13, I need one rule that generates a 1 and a different rule that when 5's put in generates a 13. For the 6th term in the sequence, I need a rule that generates a 2 so that then I can multiply it by the number that comes out of the other rule generating the 15. I could put the 7th term values in here. I think I see enough of a pattern though in this data because it's linear. This data is increasing by 1, so the rule for this table starts off 1n because my rate of change is 1. My 0 term, or my adjustment amount to make this rule work, is -4. This comes from the 2, linear stuff that we've done. This second rule definitely starts off 2n because its rate of change between consecutive terms is 2. Then my adjustment amount, or my 0 term, is a +3. So coming back over, my nth term to describe this sequence means generate a number from the n-4 rule, generate a number from the 2n plus 3 rule, and multiply them together. So that would be the factored form of my rule. I could expand if they asked me for both. For the 57th term then, I'm going to plug in n is 57 into my rule. 57 take away 4 to generate the first factor, twice 57 add 3 to generate the second factor, and when you multiply those two together you get 6,201 for that 57th term. Alright, the second one's also quadratic. And the way I know is I'm going to come over and look at the differences over on the side. I'm going from -9 to 0 to 7 to 12. That's a difference of up by 9, up by 7, increase by 5. My second difference is -2. Since my second difference is constant, it's quadratic, and I want to start to look at the factors that produce each term. 0 has too many factors, so I'm going to take it in pieces. 1 times 7, 7's prime. 2 times 6 looks promising. 0 times 8, I'm trying to back the patterns up. -1 times 9. I do those quickly because I've done these before. You may need to write out more factors to see that. I'm going to take my two different function rules that I'm looking to generate. I'm looking for a 1, 2, 3 for first 3 terms of one sequence to be this -1, 0, 1 number. And I'm looking for a different set. Notice I pulled the same n numbers off the top of my row here that I pulled down in my values down below. 9, 8, 7. I want a linear rule to describe each one of these based on the pattern that I see. I see it increasing by 1, so my rule definitely starts off n. I see them being 2 apart from my function value, so n-2 for my adjustment. Same thing here, except I see my table moving by a -1 pattern. And my adjustment here then is +10, or my 0 term. So my nth term here, n-2 times the quantity -n plus 10 for my factored rule. When I put 57 in for n in this rule, and you can use a calculator here, that'd be a great use of a calculator. Your 57th term is negative 2,585.